So this is the solution class for the electricity paper 2 class, electricity paper 2, and we're gonna see some problem from the worksheet. I am willing to start my discussion from question number 2 because there is a question over here which I want to discuss in well. So I'll pull up this PDF, all of it on the whiteboard. All right. So I was interested in this one. The important part that I want to show you, the calculation part is actually really simple. If you have a look at this calculation, it says two parallel plates P and Q are situated 8 centimeter apart in air, assuming figure 6.1. Plate Q is earth and the plate Q is maintained at partial difference plus 160 on figure 6.1. Draw lines to represent the electric field in the region between the plates. Now, what is the way that you should draw these lines to score full marks? The first thing that I would recommend that you have to draw equidistant parallel lines. Two properties: equidistant parallel lines, and because the plates are horizontal, so the lines have to be, because the plates are vertical, the lines have to be horizontal. So the way I usually prescribe the students is that take out your ruler, and if I just put it at 100%, is this a proper A4 size? I'm not sure, it might be. Take up your ruler and take a measurement for how long this plate is vertically. How long is this plate? দেখো তো কতটুকু? Is it 4.5 centimeter?
Sir, আমার তো around 4.9.
আচ্ছা, তাহলে আমার এখানে স্কেলিং এ কিছু একটা ঝামেলা হয়েছে, যাও সেটা। হ্যাঁ, so if it's 4.9, then you need to draw lines in between so that you do not, you have to cover, you have to give at least 4 lines, or if you want you can draw more. So the way I would recommend to draw this, তুমি রুলারের জিরো মার্কটাকে এখানে ধরে এখানে মনে করো হাফ সেন্টিমিটার পর পর ডট দিতে থাকো, ঠিক আছে? কয়টা ডট আসবে এখানে? কয়টা ডট আসবে? হাফ সেন্টিমিটার পর ডট দিলে কয়টা ডট হয়? How many dots do you get?
9 or 10.
Well, without the zero. I mean, we're not going to draw a line from end to end. We're only going to draw the lines inside the space. So this is going to be your first defined dot. So you're going to only hold the ruler at the 0 mark, but give the dot at half. Start giving dot at half centimeter. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 9 dots. Do the same thing over here on the inside. And then join these similar lines with a ruler, and that way you would always be sure that you have perfect parallel lines which are equidistant and you have a good looking electric field. In my opinion, this is the fastest way to draw this, and the surest way to score. Surest is cannot be actually a degree. Anyway, the sure way to score full marks out of these drawings. Anyway, the number 2 says show that the magnitude of the electric field between the plates is this much. So you just do the V by D and you get this value, and you are good to go. This is not the important bit. Anyway, this was a bit informative. I'm interested about number B. Which part? Let me show you. B number says a dust particle is suspended in the air between the plates. The particle has charges of this much and this much near the ends. The charges may be considered to be point charges separated by a distance of 2.5 millimeter as shown in figure 6.2. The particle makes an angle of 35 degrees with the direction of the electric field. On figure 6.2, draw arrows to show the direction of the force on each charge due to the electric field. This is actually pretty simple. The positive plate will experience the force in the direction of the electric field lines. The negative charge will experience force in the exact opposite direction of the electric field lines, which means you are supposed to draw horizontal arrow towards right over here and horizontal towards left over here. What is really important is that you make sure that these two arrows are perfectly horizontal or and obviously parallel with this given line, which is a horizontal line. And also, because both of these two charges are equal in magnitude, you need to be careful so that these arrow lengths are visibly equal. That's the requirement that the examiners look for, that they have to be visibly equal. I mean, they can be 1 millimeter more or less short, but whenever you're drawing, it's not very difficult for you to draw equal lines. So if you draw over here a 2 centimeter arrow length, use your ruler to draw this arrow. And if you draw it 2 centimeter, also make sure that this arrow that you're going to draw over here is also 2 centimeter. These length of arrows to represent equal forces was not a very important aspect for your O-level drawings, but from your AS and eventually up to A2, for possible cases where forces are supposed to be equal, forces are supposed to be parallel, you have to maintain those properties at least by eye. So you gotta be careful not to draw dissimilar size of arrows. এই জিনিসটা বুঝা গেছে কি সবার? কি বলছে এখানে বলবান?
জি স্যার।
আচ্ছা,
Yes,
এটুকু
sir.
বুঝলে বাকিগুলো খুব সহজ। আর এখানে নাম্বার 4টা নিয়ে আমি একটু আলাপ করব। নাম্বার 3 তে আমাদেরকে বলছে হচ্ছে এটার মোমেন্ট কত হবে সেটা বের করতে। মোমেন্টের ফর্মুলা তোমরা জানো। This is a couple, so and the actual perpendicular distance between the two particles is gonna be 2.5 sine 35 because this is 35 degree over here. So use that property and calculate the couple over here. এটা গেল। নাম্বার 4টা একটু আলাপ করছি। নাম্বার 4 বলছে suggest the subsequent motion of the particle in the electric field. Suggest the subsequent motion of the particle in the field. Now what's going to happen because of this thing, because of this force, this particle is going to start to rotate clockwise, and it is going to rotate clockwise. So let me just draw it. Can I copy this all together? Acha, actually if I copy this, can I paste it on Paint? Oh yes, I can. Beautiful. So let me just select this part, freeform selection, Control C, and let me just paste it over here. Okay, the reason I brought this figure individually, you have to consider that I'm going to start rotating this whole thing about its center. So this is going to start rotating clockwise, but as it rotates, these two arrows would maintain horizontal. But if I'm going to start drawing this roundwise, these arrows are going to change direction. So actually a good way to draw this thing, I mean to cut this thing would have been if I just erase the arrows, because the arrows would maintain that direction. So if I just start to rotate, you might actually get a wrong idea. I don't want to imprint that in your brain. So I'm rubbing off these arrows. Actually, now I can select this whole thing. Delete, paste. So what's going to happen? This is going to start rotating. And as it becomes horizontal, then it will come to force of equilibrium of force. But at this point, the object would have some inertia. And because of inertia, it's going to rotate past the horizontal orientation and it's going to start to slow down. And it's going to come to an orientation like that. Then it's going to rotate back again in this case. So it's going to keep on rotating like this. And eventually, ultimately, this positive end is going to become stationary on the right side, and this negative charge is going to become stationary on the left side. So, or in other words, I can say that these adjoining lines, this oblique adjoining line, is going to become horizontal with the become aligned with this represented electric field line, or you can say it will become parallel with the electric field line, which essentially imply horizontalness. And the positive charge would be located on the very right, and the negative charge will be located in the very left. That's how the motion will finish. So it's going to essentially go through some oscillation. It is simply not going to come over here and come to stop in the first go because of inertia. So how do you write this answer? If I was answering this question, I was writing it this way. The particle starts rotating clockwise and oscillates back and forth multiple times, and eventually it comes to rest where the positive charge is on the very right and the negative charge is on the very left. Full stop. For 2 marks, I think that's good enough. বুঝে গেছে? Palawan.
Yes, sir.
The word eventually is very important, because eventually essentially means that this will not be an immediate outcome. This will take some time, and after some time, after multiple oscillations, it will eventually, ultimately, this will be the fate. So the word eventually is very important. Don't miss out on that word. So এটা তো গেল নাম্বার 2. নাম্বার 3 আমরা লাস্ট ক্লাসে দেখছি অলরেডি, সো নাম্বার 3 নিয়ে আমি এখন কথা বলতেছি না. If you have any question, you can ask me about number 3. Rest of the questions are actually pretty simple. আচ্ছা, এখানে আমি তোমাদেরকে আরেকটা জিনিস বলবো যেটা অ্যাকচুয়ালি ইন্টারেস্টিং একটা ফ্যাক্টর, সেটা আমি একটু এঁকে দেখাই. আচ্ছা, আমি একটা জিনিস এঁকে দেখাচ্ছি. মনে করো there is an electric field, there is a positive plate over there is a negative plate over here, and there is a positive plate over here in a certain given case. An electron is placed at this position and is allowed to move freely. Obviously this electron is going to start moving towards the right because of the effect of the force obtained from the electric field. This is definitely going to happen. Now, in many cases, the question I might ask that what are the forces experienced by the electron? You have to say that the electron experiences electric force due to the electric field. Obviously, the electron, by virtue of its mass, will also experience weight. That is undeniable. But this motion from the negative plate to the positive plate will not be affected by the weight, because in this case, the electric force is working in this direction, where the weight is going to work vertically downwards. So because these two forces are perpendicular to each other, so the horizontal motion will be unaffected by the weight. Do you all understand this aspect? That a vertical force cannot affect horizontal motion. Vice versa, a horizontal force cannot affect vertical motion. So if this is a scenario where the electric force is horizontal and we are asked about weight, we have to mention that the weight is working vertically, but the electric force is working horizontally, and that's why the horizontal motion is unaffected by its weight. এই পার্টটা বুঝা গেছে কিনা?
Yes, sir.
ঠিক আছে?
Yes, sir.
This is one of the scenarios. Another scenario, let's say we have a situation where we have electric field that is vertical. Let's say we have a positive plate over here, we have a negative plate over here, and an electron is allowed to move from this place towards like this. The way we work out with this problem is that we actually calculate how much is the force experienced by the electron because of the electric field. So we simply use F equals to QE, and then we use this force to calculate the value of the acceleration, which we actually did for question number 2 in our last class for this case. But you can see over here that this particle is going to bend upwards, so the electric field is working vertically. But whenever we are going to calculate the magnitude and direction of the acceleration, we did not even bother to consider its weight. But if you think for minute calculation level, shouldn't we take care of the weight as well? Because weight is also a force. In this case, for this electron, the electric field is trying to push the electron upwards. The weight by default will always pull objects downwards. So the resultant force should be electric force minus weight. But we did not do this in our last class. But I want you to understand, why didn't we do it? The reason we do not consider the effect of weight, even when they are actually the reason we do not consider the weight for situations like this, although the weight is actually parallel to the electric field direction. In this case, on the charge particle, let's say the charge particle is somewhere over here as it enters to this point. Electric field is also working upwards and the weight is working downwards. The reason we do not consider the effect of the weight over here, or the statement that we use to get rid of the weight factor or the change created by the weight, is that the weight of the charge particle is too small compared to the force experienced by the electric field due to the electric field. Or in other words, you can say the electric force working on the charge particle is way too big compared to the gravitational force experienced by the charge particle. So whenever they are in the same alignment, I mean they are both vertical or they are both horizontal, if their alignment is same, in that case you cannot use this direction thingy. In that case, we get rid of the calculation relevant to weight by stating that the weight happens to be too small to be considerable, or weight is too small that it is considered negligible for this scenario. So whenever they are aligned, we talk about the magnitude. Whenever they are perpendicular, we talk about the direction. You cannot mess up these two explanations. We cannot say that for this case, you cannot say that the value is too small, so it was disregarded. No, you cannot say over here they are perpendicular, that's why it was disregarded. That would be wrong. Two different scenarios are explained in two different ways. Do I make sense?
Yes, sir.
ঠিক আছে? So try to remember this thing. Whenever the electric field force and the gravitational force are perpendicular to each other, we simply say because they're perpendicular, so the motion due to electric field is unaffected because by weight. Whenever they are in the same alignment means they can be oppositely working or they can be similarly working. The direction might be, their direction is parallel. Whenever they have the same alignment, in that case we say weight is too small to be considered within this calculation. It practically doesn't have any effect. What is true, the force produced by the weight or acceleration created by the weight is negligible for this scenario. That's the way we explain these stuffs. So এটা একটা additional information তোমাদেরকে আমি বলতে চাইছিলাম, because you're gonna come across this kind of problems right over here. For example, this is the scenario where we have electron over here and this is the path over here. This I would like to show you this drawing. Have a look for number 5. An electron traveling horizontally in a vacuum enters the region between two horizontal metal plates as shown in figure 6.1. So this is the electric field space. The lower plate is Art and the upper plate is at a potential of plus 400 volt. The separation of the plates is 0.80 centimeter. The electric field between the plates may be assumed to be uniform and outside the plates to be 0. On figure 6.1, draw an arrow at P to show the direction of the force on the electron due to the electric field between the plates. So they are asking us to represent the direction of force. Well, obviously this will be upwards because the positive plate is producing a stronger pull. Sketch the path of the electron as it passes between the plates and beyond them. The question already is telling you that sketch the path of the electron as it passes between the plates and beyond them, which means they are implying already that this electron is not going to hit this positive plate. It is going to travel through this electric field region and eventually emerge out. The important bit that you have to keep in mind, and the way you have to be careful to draw this curve, আচ্ছা এই কার্ভটা অ্যাকচুয়ালি আমার পেইন্টেডে ড্র করাটা একটু ইজিয়ার, সো I would like to try to draw this on paint because paint actually কার্ভ আঁকার খুব ভালো একটা সুযোগ আছে। কপি হলো না, হয়েছে? Okay, so the way I would like to draw this thing can be something like this. Okay, have a look. This is the curve drawing tool. So let me choose red maybe and thickness this much. So I'm gonna draw a curve from here to here. A bit less thickness would be better. And then I'm going to make it like that and like that. So you can see that the gradient is increasing. This is the way the curve should look like within the field. But as it comes out of the field, from this point beyond, this has to be a straight line. And this straight line has to be tangent with this point, which means the remaining path, I would like to show it to be something like this. And obviously, this would be a straight line. The reason this is a straight line because within this part we don't have any electric field existing. So this motion is unaffected by any force whatsoever. So this is a straight line path, constant velocity. And you have to be careful that you should not have any kink over here. Kink means that your line should not, at any case, look like this. I mean, let's say you draw a curve, but then you draw your straight line like this. You can see there is an angle. Or if you draw your straight line like this, you can see that there is an angle. I mean, with the red curve, this green line is not tangent with the end point of the curve. This would be wrong. You shouldn't draw that. বুঝতে পারছি বলবান?
Yes, sir. Sir,
বলো।
এই জিনিসটা যদি ইলেকট্রন পাথ না হয়, যদি আলফা পার্টিকেলস হতো তাহলে ওরা কি করতো?
জাস্ট নিচের দিকে যেত।
মানে আর্থের না নিচে প্লেটটা।
হ্যাঁ, art doesn't matter. I mean, you have to understand that the way the electric field is working is like this, from the high potential towards lower potential. So if you think for the alpha particle, I mean, if you think in terms of force, this is a positively charged plate, this is a neutral plate. Neutral plate would not apply any force on the alpha particle, but the positive plate would do what? Attraction or repulsion?
Repel it.
So together, in which direction do you get the force?
নিচে তো স্যার এটা কি হিট করবে?
Well, if it is supposed to hit or whether it is going to hit or not, that's a set of calculation that is not involved in your AS level, but we can actually calculate those. That calculation is very much similar to what I have shown you in the earlier class. We have to find out the acceleration and we have to calculate that how much vertical height does it cover as it covers the horizontal distance. If it is less
Yes,
than
sir.
if it is less than the available space, then it's going to come out. If it is more than the available space, it's going to hit.
বুঝেছি স্যার। Thank you, sir.
No problem. এটা নিয়ে কার কোনো কোশ্চেন? Anyone else?
No, sir.
Okay, then we have to see for some other problem maybe. What do we have? এটা simple problem. এটা পারবা। এই যে এখানে একটা জিনিস দেখো, this was these two plates are vertical and the electric field was horizontal. So in this case they are asking us that explain why the gravitational effects on the electron need to not to be taken in consideration. In this case you're going to say that the gravitational force works perpendicular to the direction of the electric field force. So the motion is unaffected due to gravitational force, or weight is does not affect its motion. And vice versa, if you have a look at this question number 5, where the motion of the electron was horizontal and the electric field was producing a vertical force, in this case also they have this same question. State and explain the effect, if any, on this electric field on the horizontal component of the motion of the circle. State and effect the effect, if any, of this electric field on the horizontal component of the motion. Sorry, এটা কোথায় গেল? Yeah, state and effect anything on the no, the answer is no, because the electric field is vertical force, it doesn't have any. এই কোশ্চেনে বলে নাই, অন্য কোথাও আছে, এটা দাঁড়াও দেখি বাই করে বের করে দেখাচ্ছি। এগুলো সহজ, এগুলো খুব বেশি কঠিন না, আছে কোন এক জায়গাতে আছে। আচ্ছা আমি নাম্বার 8 টা একটু আলাপ করি, নাম্বার 8 এ কিছু ইম্পর্টেন্ট কোশ্চেন আছে। হ্যাভ লুক এট নাম্বার 8 বলবান।
এটা আগে যেতে পরে আজকে যাচ্ছি 7 এর বিটা একটু এক্সপ্লেইন করুন।
7 এর বি এটা।
ইয়েস স্যার।
আচ্ছা, hello, let's have a look for question number 7. It says two parallel plates P and Q are separated by a distance of 7 centimeters, 7.6 millimeter in a vacuum. There is a potential difference 250 volt between the plates as the distance P 4.1. Electrons are produced at X on plate P. These electrons accelerate from rest and travel to plate Q. The electric field between the plates may be assumed to be uniform. Determine the force on the electron due to the electric field V by D, so that the charge change in kinetic energy of the electron as it moves from plate P to plate Q is 4.00 and 10 to the power minus 17 joule. This is calculated by E equals to VQ. So Q is the charge of the electron, V is the voltage difference, and that work done basically converts into the kinetic energy of the electron. So you just calculate how much work was done on this electron. E equals to VQ.
Do we have this formula equals to VQ?
This one.
Yeah. In our syllabus.
Yeah. The definition of voltage has been in a syllabus since your O level. This is the definitive equation for voltage, energy per charge. So if you just cross, you get energy equals to VQ. Yeah, it is a part of your syllabus. Anything that you've learned in O level.
Yes, sir. Yeah.
Moving on. So then it says determine the speed of electron.
বুঝছি।
আচ্ছা এখন পারবা?
হ্যাঁ।
আচ্ছা ঠিক আছে, মানে ওই ইকুয়েশনটা দিয়ে করতেছি বলে আচ্ছা ওকে, হ্যাঁ তাহলে বুঝছি। আচ্ছা নাম্বার 8 এর ড্রয়িংটা নিয়ে আমি একটু আলাপ করবো। নাম্বার 8 টা একটু দেখি। স্টেট হোয়াট ইজ মেন্ট বাই অ্যান ইলেকট্রিক ফিল্ড। Hold on, give me a moment.
Okay, sir.
All right. I didn't have much of a boss earlier, but now I do. Boss cries every once in a while. 8B, the electric field between an earth metal plate and two charged metal sphere is illustrated in figure 5.1. On figure 5.1, label the spheres plus or minus to show its charge, which is very simple. You draw a plus and you draw a minus over here. On figure 5.1, mark a region where the magnitude of the electric field is constant. Label this region C, decreasing, and yeah. Now, what you have to understand that this, if you have a look, let me zoom in. If you have a look at the orientation of these electric field lines, you can see that from here to here, for this much space, I mean, for all of this much space, the separation between the electric field lines is increasing, which means this is the region where the electric field is becoming weaker, all the way up to the earth metal plate. From the earth metal plate on the right side, for this much region, let me label this with green maybe, for this much region, you can see that from left to right, the electric field lines are becoming closer, which means the electric field is slowly becoming more and more stronger. Now, you can see that these are continuous curves. So at which position is the electric field actually uniform, or electric field is constant? The electric field, magnitude of the electric field is only constant at which the field lines are parallel. But you can see it very well, these are curved lines. Curved lines are not parallel. So if you want to find out a region where the curved lines are parallel, the only way to judge them by their tangents. So if you think of all the different positions, if you draw multiple different tangents across multiple different vertical sections, the only location where those tangents, these are the section lines that I want you to think. These are not the tangents. Tangents would be tangent with the curves. The only location where those tangents can be parallel to each other is exactly on this earth metal plate. If you draw the tangents over here, these tangents would be perfectly parallel to each other, representing a constant / uniform electric field. The width of this uniform electric field is actually very small because it is only a very small space. But this is the only location where the electric field can be considered to be uniform. On this region, the electric field is becoming weaker. For all of this region, the electric field is becoming stronger. So in this case, the figure my point is where the magnitude of the electric field is constant. If I was answering this question, I would label right on the body of this earth metal plate, right over here. And then it says on figure market region with where the magnitude of the electric field is decreasing. So I'm going to draw it anywhere on the left side, preferably on the left of these arrows. So I'm going to write D over here, not outside the field. The most common mistake students do is that they feel like that I should not draw on the electric field, and they write those C and Ds over here and over here. There is no electric field even drawn, so that would be insane to do. Draw your letters, write your letters in the electric field where you are supposed to do. বুঝে গেছে?
বুঝি নাই কেন ওখানে ডিক্রিজিং হবে,
কোথায় উপরে লিখলে কি হবে?
ডিক্রিজিং কেন হবে?
Because the field lines are becoming farther apart. Gaps are small, getting bigger between the electric fields. Increase larger gap between the electric field lines represents a weaker field. Closer gap represents smaller gap, or closer lines represents a stronger field. So you have to understand this is the part where the fields are strong.
Right. Yeah, got it. Thank you.
No problem. And nine. Last question again. I'll ask first. So we have, oops.
Sir, electric field uniformity কোনো charged particle kinetic energy affect করবে না কেন?
Ideally
Kinetic
not.
energy per speed.
Ideally not. You can have, I mean, the amount of energy, kinetic energy obtained by a charged particle is exclusively dependent on its own charge value and the voltage within which you're accelerating. For example, let's say if you accelerate an alpha particle through a potential difference of 200 volt, if you place those 200 volt plates, if you place those 200 plate potential difference plates at 2 centimeter distance, the amount of energy that the electron is going to get, electrons are going to get the same amount of energy if you keep those 200 volt plates at 10 centimeter. The idea is very simple. When the plates are placed closer, you have a very strong electric field. So the force is large. So the electron will gain some energy under the effect of a large force, but covering a small distance. So F is big, where X is small. If you make the plates farther apart with the same potential, your electric field is going to become weaker. And as a result, the resultant force on the electron will be on the alpha particle or the charged particle will be small, but it will be experiencing that force over a longer distance. So in this case, your force is smaller, but you have an increased distance to cover up for that same amount of energy now. Gathering to acquire the same amount of energy. বুঝতে পারছি?
Yes, sir.
Okay, and then we have these questions and the similar questions that we have. Okay, number B is actually a bit interesting question because number B is about the conservation linear momentum. So let's have a look at this question a little bit. Have a look. Two oppositely charged metal plates are illustrated in vacuum as shown in figure 7.1. So we have charge plus Q, speed V, positive charge plate and negative charge metal plate. The plates have length L. All right. So we have the two positively charged metal plates are situated in a vacuum as shown in this figure. We have this particle coming in and it is entering from the electric field from the left. The plates have length L. The uniform electric field between the plates has magnitude E. The electric field outside the plate is 0. A positively charged metal sphere has we have basically actually yes. In B number it says state the law of conservation for linear momentum. You just write the law, you know what it is. In B in 2 it says use your answers in A2 to state an expression for the changing momentum of the particle. This is not going to be difficult because in this expression you actually calculate what is the force and you also calculate the time. So you know that delta p is equals to force into time. So all that you have to do is write a multiplication representation of these two expressions that you calculated over here. And then it says search and explain whether the law of conservation of linear momentum applies to the particle moving between the plates. Here's the deal. Law of conservation of momentum essentially is derived from Newton's third law. F1 equals to minus F2. And Newton's third law is such a law that is universal everywhere. For the case of galaxies and universes and celestial bodies, all the way up to even the very subatomic particles, everything is under the effect of Newton's third law. If there is an action force, there will be an equal and opposite reaction force. There is no change, no exception of Newton's third law, which means the conservation of momentum law is also equally applicable for this case. Now you want to think that in this case, as the positively charged particle actually enters, this particle is going to be bending upwards because this is the positive plate, this is the negative plate, attraction of upwards and repulsion upwards. So together the particle is going to go upwards. So this particle is going to gain some momentum, or it's going to have some change of momentum because of the force it is experiencing. By the law of conservation of momentum, the thing that is producing this force, which is the electric field, or in other terms, the structure of these two plates, they will also be under the effect of the same momentum change for the duration the particle travels through this plate. Which means I can show you something like that. Let's say if these two plates are not held in place by a very rigid support, let's say we have hang these two plates by a bit of a spring over on top and having a bit of a spring over here at the bottom, and they are now maintaining this electric field. The moment the particle will enter, the particle is going to start traveling upwards, and these two plates, both of these plates, are going to be pulled a bit downwards. So they're going to undergo a bit of a jerk or a bit of a shake. I'm using the term shake because this particle is going to cross through this electric field pretty fast. The moment the particle is going to go out of this field, these two plates are once again come back to the original position. But obviously there will be a bit of a vibration, ongoing vibration, because because the system wood is not essentially. I didn't describe the system to be damped properly. Only two springs are attached to the two plates. So you'll see that small bit of vibration happening to these plates. Although there is no physical contact, but for just third law to be applicable, you don't need physical contact. এই আইডিয়াটা বুঝা গেছে কিনা? Particle is pushed up, so the thing which is pushing the particle up, electric field, essentially produced by the two plates, they'll be pushed down by the same momentum change for the same duration. Make sense?
Yes, sir.
এই ফিগারটা কি তোমার গ্রাফটা কি আঁকতে পারছো প্রবান?
না স্যার।
আচ্ছা, এই গ্রাফটা নিয়ে একটু আলাপ করি। Question number 10 it is. Question number 10 says two large flat metal plates A and B are placed in wrapper in a vacuum as illustrated in figure 5.1. On figure 5.1, draw an arrow to indicate the direction of the electric field between the plates A and B. So you just follow the exact same mechanism. Draw at least 4 lines. That's my earnest request. Drawing 3 lines is usually okay, but in many of the mark schemes I've seen that they expected the students to draw at least 4 lines. So always practice to draw electric field lines or magnetic field lines by at least 4 lines. That's actually a safe way to go for. Then this is calculate the electric field strength between A and B, and electron is released from the rest at surface plate of A, so that the electric energy and then movement to B determines speed of the electron energy in plate B. যারা এই কোশ্চেনটা অলরেডি সলভ করো নাই, I would like all of you to solve this question up to B2. I'll give you 5 minutes. And then I'll help you for the graph. 5 minutes. আর যারা অলরেডি সলভ করে ফেলছো তারা বাকি প্রবলেমগুলো দেখা, যারা পুরো ওয়ার্কশিট সলভ করে ফেলছো অন্য কোনো পড়াশোনা করতে পারো, বা হচ্ছে আগের চ্যাপ্টারগুলো রিভাইজ করতে পারো। If you have already collected your mock papers, you can mentally prepare for your preparation. Do something. যারা করো নাই তারা এখন করা শুরু করো। I'm pausing the recording. Damn it. Acha. I just resumed the recording. I forgot to resume the recording, and this is the problem. I'm just gonna go pretty fast to describe how this was done. I forgot to do the recording. This is a graph of distance over instantaneous velocity, final velocity over distance. So we wrote the equation over here, which relates v and d, and initial speed of 0. So this becomes this, and this becomes this. This is a graph that we know by shape, that is a decreasing gradient shape. So we draw a decreasing gradient shape over here. Just a second, Polapan. So we know that this graph is a decreasing gradient shape, so that we have to draw the decreasing gradient shape. And to make sure that the examiner knows what we're doing, we had to finish the graph up to 9 centimeter, because the figure shows us that the space between the two places was 9 centimeters. So this graph cannot be drawn beyond that point. And also we have to be careful so that the end point of the graph does not appear to be horizontal. It will lose gradient, but it should not appear to be horizontal. We have to be careful about that. And obviously the graph should not be like this as I've drawn. This was drawn on a right pad, so I'm not very good at drawing on this. So this kind of a bend shouldn't be there. It should be a smooth curve with decreasing gradient, not appearing to be horizontal at the end. And just to make sure that the examiner know that what you're doing, you can draw a bit of a dotted line over here and label 9 over here. So that's actually more precise and well done. Okay, any further problem from the for the other worksheets that you have attempted and couldn't solve for relativity chapter or anything else? I'll take questions now. ইয়ার নাম্বার বলতে পারো, and then or you can directly send a screenshot of the problem in the messenger. We can pick up those problems because we have time. Anyone? মকে কপি কালেক্ট করছো কে কে? when topic test কপি কালেক্ট করছো কে কে?
Sir, I did.
Sir, I did too.
আচ্ছা, থ্যাংক ইউ ফর দ্যাট। আর একটা জিনিস একটু তোমাদেরকে বলছিল হচ্ছে, তোমরা মকে সবগুলো কপি সেন্ড করবা হচ্ছে ইয়াতে, ওই যে কোথায় আমার যে সেকেন্ডারি অ্যাকাউন্ট আছে ওইটাতে, মানে হচ্ছে এই অ্যাকাউন্টটাতে, এই যে যেখানে যে ইয়ার ছবি দেওয়া আছে, এটা হচ্ছে কে? এটা হচ্ছে শেলভি, থমাস শেলভি। হ্যাঁ, থমাস শেলভির একটা পোর্ট্রেট দেওয়া আছে। সো এটাতে পাঠাবা সব জিনিসপত্র। আর হচ্ছে মকটা ইউ হ্যাভ রেড দ্য রুটিন ইনস্ট্রাকশন দেওয়া আছে। একটা জিনিস বলে দেওয়া হয় না, সেটা হচ্ছে যে তোমরা মকের কপিগুলো রিনেম করবা হচ্ছে এই ফরম্যাটে। আমি একটা জাস্ট কপি দেখাই, মনে করো হচ্ছে সাইনা জামান, এই যে আচ্ছা এখানে এই যে এরকম এখানে স্টুডেন্ট আপলোড করছিল এইভাবে, বাট উই অ্যাপ্রিশিয়েট দ্যাট ইউ রাইট ইট ইন দিস ম্যানার। সো তোমরা আপ করবা হচ্ছে আগে রোল নাম্বার দিবা, আন্ডারস্কোর তোমার নাম দিবা, আন্ডারস্কোর কি দিলা। ফর এক্সাম্পল মনে করো হচ্ছে তুমি টপিক টেস্ট দিচ্ছ, টপিক টেস্টের A1 এর পেপার 1 দিছো, সো ইউ ক্যান রাইট A1 P1 এন্ড এক্সামিনার এটা চেক করার পর, এগুলো হচ্ছে মনে করো চেক কপি। এক্সামিনার চেক করার পর জিনিসটা এখানে চেকড লিখে আবার তোমাদের ওই একই চ্যানেলে রেজাল্ট ডেতে অপটিমিস্টিক্যালি রেজাল্ট দিতে তোমাদেরকে আবার ব্যাক করে দিবে। সো এখানে স্টুডেন্টগুলো অনেকগুলো পরীক্ষা দিছে, অনেকগুলো পরীক্ষার এখানে রেজাল্ট দেওয়া হয়েছে, আর অনেকগুলো দেওয়া হয় নাই। সো আস্তে আস্তে সবগুলো দেওয়া হবে, এক্সামিনার এগুলো আপ করবে। আর যেমন মনে করো হচ্ছে এই পেপারটা দেখতে কিরকম, আমরা দেখেন ডাউনলোড হলো। সো ইফ ইউ হ্যাভ আ লুক, এই যে সাইনা জামানের পেপার। সো কভার পেজ সহ স্ক্যান করবা, দিস ইজ ভেরি ইম্পর্টেন্ট। সো এখানে আমরা আসতেছি যে এই যে বান্দা এখানে দিছে, সো এখানে একে এক পাইছে, এই একে এক পাইছে। দিস আর দ্য নাম্বার প্লেস বাই দ্য এক্সামিনার এখানে ভাগ করে দিছে। দেখো এই গ্রাফের রোল ছিল 5। সো অ্যাকর্ডিং টু দ্য মার্ক স্কিম, this kid only scored the second and the third mark. This kid did not score the first, fourth and fifth mark. They'll have their mark schemes, and you'll also have your mark schemes, and marks will be given in this manner so that you know precisely which are the marks that you did not score. And that's basically it. They only wrote these numbers with red, and it goes on like this all the way up to the end, and eventually these numbers were added on the cover page and the percentages were given, and that's basically our working field. বুঝা যাচ্ছে? সো পেপার এইভাবে তোমাদেরকে ডেলিভার করা হবে এবং মকটা এই সিস্টেমে হইতেছে এখন। এটা জাস্ট একটা এক্সাম্পল হিসেবে দেখাইলাম। বুঝছো কি বলছি?
ওকে স্যার।
সো তোমরা এখানে আমার থেকে পেপার নিবাই, ফিজিক্যাল কোনো পেপার আমাকে ব্যাক করবা না, ফিজিক্যাল কোনো পেপারই আমাকে ব্যাক করবা না। তোমরা সবাই এই নতুন অ্যাকাউন্টে করছো না, পাঠাইছো না? আচ্ছা, আরেকটা জিনিস বলি, সেটা হচ্ছে এই পিডিএফ গুলো বের করার জন্য তোমাদের তো মোবাইল থেকে ছবি তুলতে হবে। মোবাইল থেকে ছবি তোলার পরে তারপর সেই ছবিগুলো আমাকে আবার শেয়ার করতে হবে। ঝামেলা যেটা হচ্ছে যে ডিরেক্ট মেসেঞ্জার থেকে পিডিএফ মোবাইল থেকে অ্যাড করা যায় না। So you have to first transfer these post PDFs to your PC if you have a PC, if you have access to a PC, if you use a PC to do your classes and stuffs, and PC থেকে তুমি খুব ইজিলি এটা এখানে পাঠাতে পারবা। আর যদি তোমার পিসিতে এটা ট্রান্সফার করার মতো টেকনোলজি মেকানিজম হেল্প না থাকে, সেই কেসে তোমরা মেসেঞ্জার লাইট ইউজ করতে পারো। মেসেঞ্জার লাইট দিয়েও পিডিএফ পাঠানো যায়, যেটা ডিরেক্ট মানে অরিজিনাল মেসেঞ্জার যেটা সেটা দিয়ে পাঠানো যায় না, which is weird but that's the fact. So you can use messenger lite to share those things, and if that is also unable, if you don't want to do that or if it's difficult for you, if you use cam scanner এর সার্ভার সরাসরি পিডিএফটা আপলোড করে ওই লিংকটা শেয়ার করে দিবা। ফর এক্সাম্পল যেখানে আমাদের একটা স্টুডেন্ট আছে, অনেক স্টুডেন্ট অ্যাকচুয়ালি আমাদেরকে লিংক দিয়ে পিডিএফ শেয়ার করছে, যেমন এই হচ্ছে একটা আব্দুল মনে একটা স্টুডেন্ট, সে ক্যাম স্ক্যানার থেকে লিংক দিছে, এন্ড এ মানে আমাদের এই স্টুডেন্ট যে জিনিসটা করছে সেটা হচ্ছে যে হি অ্যাকচুয়ালি শেয়ার্ড আস এ এনক্রিপ্টেড কপি এন্ড ইউজ দিস কোড ফর ইচ ইন্ডিভিজুয়াল পিডিএফস টু বি ভিজিবল। সো প্রেফারেবলি তোমরা যদি এনক্রিপ্টেড না করে নর্মালি মানে পাবলিক শেয়ারিং হিসেবে আপলোড করো তাহলে খুব ভালো হয়। আর যদি এইভাবে শেয়ার করো, এইভাবে যদি আমাদেরকে পিডিএফ গুলো শেয়ার করো ক্যাম স্ক্যানার সার্ভার থেকে, তাও হবে। এক্সামিনার এখান থেকে ডাউনলোড করে জিনিসগুলো ইভেন্চুয়ালি চেক করে নেবে। বুঝতে পারছি?
দিয়ে হবে না?
হ্যাঁ
স্যার, আমি ফোন দিয়ে পিডিএফ পাঠাতে পারি মেসেঞ্জারে। I don't have any problem with that.
How is it
I use PDF element বলে একটা অ্যাপ আছে, ওটা ইউজ করি।
ওটা কি মেসেঞ্জার, ওটা থেকে ডাইরেক্টলি মেসেঞ্জার শেয়ার করা যায়?
জি স্যার।
নাম কি অ্যাপের?
এন্ড স্যার আমি অ্যাডোবে স্ক্যানটা ইউজ করে ওখান দিয়ে স্ট্রেট অ্যাওয়ে পিডিএফটা পাঠানো যায় স্ক্যান করার পরই।
আচ্ছা ঠিক আছে, if it's possible for you that's very good. I mean I'm just telling you the solution that I have come across through the last month's experience, because so if you can actually send us the PDF in that originally renamed format, for example something like this, mock 4 T1 1161 Chandima Poddar, so she sent these things and the examiners eventually downloaded those, they renamed those things in their own convenient format and eventually send this back. So if you can send it in this format, very good. If you can't, then you either have to use Messenger Lite or you have to share the cam scanner links if that's the case. Any further question, Polaban?
না স্যার।
আচ্ছা তোমাদের পরীক্ষার জন্য টপিক্সের পরীক্ষার জন্য আমি কয়েকটা একটু ইনফরমেশন বলতেছি। সেটা হচ্ছে টপিক্সের পরীক্ষা তোমরা যে টপিকগুলোর উপর দিবা, what I really recommend যে পরীক্ষাগুলো দেওয়ার আগে ক্লাস নোটস একবার ভালো করে পড়বা, ওয়ার্কশিটগুলো একবার উল্টায় দেখবা যে ওয়ার্কশিটে কোন কোন প্রবলেমগুলি পারো নাই, ওয়ার্কশিটে কোন কোন প্রবলেমগুলো তোমার করতে সমস্যা হয়েছে, স্পেশালি ডেসক্রিপটিভ যে প্রবলেমগুলি আছে। মনে করো হচ্ছে 6 মার্কের কোশ্চেন, দেখা গেল যে 5 মার্ক হচ্ছে ডেসক্রিপটিভ, লাস্টে একটা 1 মার্কের, 5 মার্ক হচ্ছে ম্যাথমেটিক্যাল, লাস্টে একটা 1 মার্কের ডেসক্রিপটিভ কোশ্চেন আছে। 10 মার্কের কোশ্চেন 8 মার্ক হচ্ছে ম্যাথমেটিক্যাল, লাস্টে একটা 2 মার্কের একটা ডেসক্রিপটিভ কোশ্চেন আছে। এইগুলা খুব ভালো করে রিভাইজ করবা। দিস আর দ্য কোশ্চেন্স ওয়্যার ইউ আর স্টুডেন্টস আর মোস্ট লাইকলি টু লুজ মার্কস। এগুলো ভালো করে রিভিশন করবা। কোথাও কোনো কনফিউশন থাকলে স্ক্রিনশট মেরে আমার ডিরেক্ট প্রোফাইল, এই প্রোফাইলে না, আমার ডিরেক্ট প্রোফাইলে আমাকে পাঠাবা যে স্যার এই জিনিসটা ভুলে গেছি, এই জিনিসটা মনে নাই, একটু বলে দেন, I'll respond in my earliest convenience. ঠিক আছে? এন্ড তারপর পরীক্ষা দিবা এবং পরীক্ষা নিয়ম করে দিবা। এমন না যে পরীক্ষা দিতে বসলা চিপস খেতেছো, তারপর হচ্ছে তুমি কিছু ডোরেমন দেখলা, এগুলো যাতে না হয়। বুঝছো কি? পরীক্ষার ডিজাইনে দাও, কারণ পরীক্ষার ডিউরেশন গুলো ভেবে দেওয়া আছে, সো দ্যাট ইউ ক্যান অ্যাকচুয়ালি হ্যাভ এ মেন্টাল সেটআপ দ্যাট আমার এতটুকু টাইমের মধ্যে এতটুকু লেখা করে শেষ করতে হবে, এটা যাতে অ্যাচিভ করা যায়। এটা হচ্ছে রিকোয়েস্ট। আচ্ছা তাহলে একটু বন্ধ থাক, তোমাদের যদিও সময় আছে তোমরা অন্য পড়াশোনা করো বা হচ্ছে ফিজিক্সের পাস্ট ইয়ার প্রবলেম সলভ করো, যেমন হচ্ছে অ্যাটমিক ফিজিক্সের প্রবলেমগুলো সলভ করলে আরো কিছু প্রবলেম সলভ করলে একটু ভালো হতো, কারণ এই প্রবলেমগুলো ওয়ার্কশিট আমাদের ছিল না, স্পেশালি দ্য কোয়ার্ক স্ট্রাকচার প্রবলেমগুলো। আমরা ডিসকাশন ক্লাসে কিছু প্রবলেম দেখছি, বাট অন্য ইয়ারগুলো প্রবলেম যদি পাও সলভ করলে ভালো হতো আর ভালো হয় আর কি। আর হচ্ছে অল দ্য বেস্ট ফর ইউর টপিক টেস্ট। যারা এখনো কপি কালেক্ট করো নাই, প্লিজ ডু কালেক্ট দেম, বিকজ ইফ ইউ হ্যাভ আ লুক ওভার হিয়ার ইজ মাই রুটিন শর্টকাট, এই হচ্ছে রুটিন। এই যে দেখো B1 C1 D1 E1 F1 এটা দিতে হবে। ইস্যু ডেট হচ্ছে 1 থেকে 3 আর স্কেডিউল হচ্ছে 1 থেকে 10। সো যারা অলরেডি কপি কালেক্ট করছে অলরেডি পরীক্ষা দেওয়া স্টার্ট করতে পারো। এখানে টোটাল পেপার আছে হচ্ছে কয়টা, পাঁচটা মক নাম্বার, হুইচ মিন্স ইটস অ্যাকচুয়ালি 10 পেপারস, কারণ প্রত্যেকটার মধ্যে P1 আছে P2 আছে। সো B1 মানে হচ্ছে বি টপিকের, বি কি দিয়ে বানানো, বি হচ্ছে ওয়ার্কশিট 2 একলাই, মানে কাইনেমেটিক্স এর মোমেন্টাম একলাই হচ্ছে বি। সো বি তে B1 আছে B2 আছে। এ হচ্ছে ওয়ার্কশিট 1 + 11, which means topic A is made up from measurement technique, uncertainty stuffs and also the radioactivity. A1 আছে শুধু একটা, এটা আমি সেকেন্ড সেশনে দিছি কারণ হচ্ছে আমরা radioactivity একদম লাস্টে পড়াইছি। I have given this on the second session যাতে করে তোমরা আরো কিছু ফার্দার প্রিপারেশনের জন্য টাইম নিতে পারো। সো পরীক্ষা কিন্তু 10 তারিখের মধ্যে দিতে হবে। দেখো আপলোড ডেডলাইন দেওয়া আছে 11:59 PM, এই সময়ের মধ্যে আপলোড করতে হবে। সো তুমি পরীক্ষা দিতে দেরি করলা, তারপর বললে স্যার কারেন্ট চলে গেছিল, ইন্টারনেট ঝামেলা করছিল, এগুলা কিন্তু তখন খাটবে না। বুঝে গেছে? আর এমন না যে তোমার সবগুলো পরীক্ষা দিয়ে একসাথে আপলোড করতে হবে। তুমি যদি মনে করো B1 এর দুইটা দিয়ে ফেলছো, P1 P2 ইমিডিয়েটলি আপলোড করে দিলা, কোনো সমস্যা নাই। এক্সামিনার মতো নিয়ে চেক করে ফেলবে। কিছু বুঝলা?
Yes, sir.
ওকে
জি
স্যার।
স্যার।
স্যার আমার না ইলাস্টিসিটি নিয়ে একটা জিনিসের প্রবলেম ছিল।
ঠিক আছে, সমস্যা নাই। তুমি ওই জিনিসটা আমাকে মেসেঞ্জারে পাঠাও। দরকার হলে আমরা একটা নেক্সট ক্লাসে দেখলাম, যদি ভালো প্রবলেম হয় নেক্সট ক্লাসে সবার সাথে আলাপ করলাম, নাহলে যদি ইন্ডিভিজুয়াল প্রবলেম হয় নট সো সিগনিফিকেন্ট, তোমাকে আমি ইন্ডিভিজুয়ালি বুঝিয়ে দিলাম। ইট ক্যান বি অ্যারেঞ্জড।
Thank you, sir.
Sure, no problem. All right, kids. That's it for today. Thank you very much. Allah Hafiz. Assalamu alaikum.
Walaikum assalam, sir.
ওয়ালাইকুম আসসালাম স্যার।
স্যার।
All the best. I hope you don't need it, but I think you'll need it.